Swazdi Tukon. Today we're going to look at the last section in chapter 11 that we're going to be covering, which is about arc lengths and areas of sectors. Now there's one new term in there that we haven't done yet, and that is this idea of a sector. So let's quickly define that. A sector of a circle is a region bounded by two radii of the circle and the arc they intercept. So what does this mean, to bound a region? It means to kind of create the borders of a region. So two radii and an arc are creating a border for a region in a circle. So what we have here is something like, we have a radius AD, and we have a radius AB, and we have this arc BD. Together, those three things, they bound this region right here that kind of looks like a slice of pizza or a slice of pie. So that thing is considered to be a sector of circle A. It also you could name that sector. You would name it basically by naming the central angle that the two radii would create. So those two radii create this central angle right here, which is angle BAD. So that sector could be called sector BAD, or you could call it sector DAB. Of course, you could reverse those letters. So that's what a sector is. Now what we're going to be looking at is how to calculate the area of that sector, but also how to calculate the length of a segment, right? The length of, not a segment, the length of an arc that those two radii are intercepting. So we're going to be doing both those things in this video. So first of all, let's look at how we would calculate the arc length. If that arc had a measure of x, so if arc BD has a measure of x, then the length of arc BD will be calculated by doing x over 360 times 2 pi r. And essentially what we're doing here is we're taking, since this 2 pi r part, since that is basically the circumference of the circle, essentially what we're doing is we're taking that circumference and we're multiplying it times a fraction that is sort of the portion of the full circle that the arc represents. So in other words, if this is a 60-degree angle, right, then 60 degrees is 1/6 of a full circle, or 1/6 of 360. So it makes sense that this arc would be 1/6 of the full circumference of that circle. That's really what this formula is telling us. Now when we're doing the area of a sector, it's really the similar idea. We're going to take the arc measure over 360, and we're going to multiply that times pi r squared, and of course pi r squared is the formula for the area of the circle. So the same idea, we're going to take, what portion of a full circle does the arc represent, and we're going to take that fraction and multiply it times the area of the full circle. So if the arc is half the circle, if it's a 180-degree arc, then the area would be half of 180 over 360 would be 1/2 of the full area of the circle. So that's the basic idea here. Now let's take a look at some examples that we can work out. We have a chart here, and within this chart we are supposed to, we're always going to be given the angle measure, and some of the time we're given the radius, and we have to calculate the arc length and the sector area. Then these last two columns, we're given the arc length or we're given the sector area, and we have to calculate whatever's missing. So let's start here with the first column. We have a 90-degree central angle. So in other words, if you think of the circle, we have a central angle that looks like that. Now that chunk of the circle looks to be about 1/4 of the circle, right? So it would make sense that the area would be 1/4 of the full circle. The arc length would be 1/4 of the full circumference. Now, how is that going to come up as in our calculations? Well, to do the length, what I'll do is I'll take the angle measure or the arc measure, because those of course are going to be the same, and we're going to put that over 360, and we're going to multiply it times 2 pi times 8. Now it says we're supposed to leave our answers in terms of pi, so we're not going to be multiplying out the pi. We're going to leave that in there. We're going to see a pi in our answers here. So what do we do here? How are we going to clean this up? Well, let's first take this 90 over 360 and let's reduce that fraction. that reduces down to 1 over 4 because essentially I can take both of them and divide them by 90. 90 divided by 90 is 1, and 360 divided by 90 is 4, so that's 1 over 4. Times 2 pi times 8. If I'm leaving my answer in terms of pi, really what I want to do is multiply the 2 times the 8 to get 16, and then slap that pi on there. And I'm going to put that over 1, because now what I need to do is multiply 1/4 times 16 pi over 1. And of course we know that means we just multiply the numerators together to get 16 pi, and we multiply the denominators together and we get 4. And now I have 16 pi over 4. But that can be reduced because I can divide 4 by 4 and get 1, divide 16 by 4 and get 4. So now I have 4 pi over 1, which is just going to be 4 pi. So that's the length of our sector. That's the length of the arc. Now the area of the sector, we're going to do somewhat the same idea. Here, I'll switch over to red for these calculations. Kind of the same idea, right? Excuse me. We're going to take 90 over 360, but now we're going to multiply it times pi r squared. So that's going to be pi times 8 squared, since our radius is 8. So this will be 1/4 times 64 pi over 1. So this will turn into 64 pi over 4. Now I can reduce these both, I can divide both of these by 4 again, so that'll be a 1, and that'll turn into a 16. So now we're looking at 16 pi. 16 pi for the area of that sector. It's just the full circle's area, 64 pi, times the portion of the full circle that our sector represents. It's 1/4 of the circle. I know that because 90 over 360 is 1 over 4. Okay, let's move on to the second column. We have a radius of 2 and an angle of 45. So for the arc length, I'll have 45 over 360 times 2 pi times 2. 45 over 360. Now that's going to reduce. You could probably use your calculator to do that reduction. I think I've shown you how to do that before. It's going to reduce down to 1 over 8. And that's going to be multiplied by 4 pi. So we put the 4 pi over 1. We multiply numerators and denominators. And now we have 4 pi over 8. Reduce this by dividing by 4 on the top and the bottom. You get 1 and 2. So now this is going to be pi over 2 is our final answer. Pi over 2. For the sector area, we're going to take 45 over 360 again, multiply it times pi r squared. Well, look at what's going to happen here. Again, we're going to have 1 over 8, but now we have, oops, that's going to be a times, sorry, times 4 pi again. It ends up being the same thing as the arc length. That's just a coincidence. That doesn't always happen, obviously. We didn't get the same answer in the first column, so this obviously doesn't always happen. But here it happens. We have 4 pi over 8 again, which we already know is going to reduce down to pi over 2. Just a coincidence. Now in this third column, we start off with a radius that has a radical in it. So we got to do some work with radicals here. We're going to set up our formula as 120 over 360 times 2 pi r, or 6 root 2. Now 120 over 360, that's 1 over 3. 2 pi times 6 root 2. What we're going to do is we're going to multiply the 2 times the 6 root 2, and then we'll stick the pi in there. So 2 times 6 root 2 is 12 root 2. So we're going to write that as 12 pi root 2 over 1. So now when we multiply all that together, we have 12 pi root 2 over 3. We can simplify by dividing that by 3 and turning it into a 1, dividing the 12 pi root 2 by 3, which just turns the 12 into a 4. So now we have 4 pi square root 2. 4 pi square root 2. Okay, so for the area of the sector, again, this is 120. 120 over 360 times pi times radius squared. 120 over 360 will be 1/3. Now when I do 6 root 2 squared, remember I got to square the 6 and I got to square the square root 2. So this turns into 6 squared is 36 Square root 2 squared is 2. So this will be 72 pi over 1. So now I have 72 pi over 3 when I multiply those together. Divide top and bottom by 3, and I end up with 24 pi over 1, or just 24 pi. Okay, now these last two I'm going to save for in class. We'll go over these in class. I'll show you how we're going to set them up, and then I'll show you, and then in class we'll work them out. So what's different is, of course, we now have the length of the sector in this column. We have the area of the sector in this one. I'm sorry, I said the length of the sector. I meant length of the arc right here, and area of the sector right here. So what we're going to do is we're going to have to set up an equation that we're going to solve for r. So in the first column, or in this column right here, we'll have our angle measure over 360 times 2 pi r, which should come out to equal pi over 3. Now this is going to it's going to be a bit of an ugly equation to solve, but we're eventually going to try and solve that for r. Okay? On this problem right here, we're going to have the same idea. We'll have, in this case, it's an angle of 270. So we'll have 270 over 360 times pi r squared. It comes out to give us 16 over 3 times pi. Okay, so we'll look in class how we're going to solve these. For right now, we'll leave it at that, and I will see you soon.